Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 20, we continue with classes and instances, but of course we talk about in Python examples. And the concepts that we will cover, classes and instances in Python. We will talk about inheritance in Python. We will show you examples of polymorphism using Python. And finally, we will give you some more complicated examples. And one of those examples would be an agent-based simulation. So, we have already learned about classes and instances in the previous lecture. Now we show you how it is implemented in Python programs. So as we know, classes are blueprints for creating objects. So that's based on the structure of the class, objects are created, and these objects are instances. So that means instances of the class. So instances are actual objects created from those particular blueprints given in the class. And to give you an example, let us take the example of a city management system where each city has attributes like name, population, budget, and so on. Now, the class will be the city, so which defines the attributes and behavior of a city. So, and then the instances would be city 1, city 2, so that we can have many cities, based on that particular class. And then the attributes for this particular instances or these objects, or based on the structure, of course, given in the class, could be like the name of the city, the population of the city, or the budget of the city. And of course, when we put that in the instance, each instance will have unique values of this. And then there would be methods as well along with the attributes, which is like display information. In this, it's a simple method, like I just want to display the information what is there in for each city. So that means for each object I can call this particular method, and it will display the information which is there in this particular class, in this particular object. So now we introduce something called a constructor. A constructor is a special function inside a class that runs automatically when an object is created to initialize the object's data or the attributes. That means whenever we are initiating an object, that means we say create object of a type class of something, right? So when I create that particular object, automatically the object needs to be filled with data for those particular attributes, right? So the function which actually does that is known as the constructor. So let's see how it looks like. So in this program, the same program that we are talking about, we have the class city. First we have to, in a program, we have to first define the class, and then we have to write the main body of the program, right? When the class ends, automatically the main body starts, or we can show that this is the starting of the main program by saying def main as well, right? So we can also write in that way. So in this particular program, you can see this class city, where first we are putting to the constructor. That means the first program is a constructor, def underscore init underscore self name population budget. So these are the arguments which are getting inside this initialization function or the constructor. And what we are storing is self.name equal to name. That means within this object I am storing the name within myself. So that means in the name attribute I am storing the name. Then self means, because we are initializing that, that's why we are using this this self, this argument. So I am initializing within myself the different attributes. So that's why self.name equal to name, self.population equal to population, and self.budget equal to budget. That means within this class I am putting name, population, budget, storing them, initializing them first within myself. And then we are adding this function def display info, again of self data, that is print f string city name, the self dot name, f string population self dot population, f string annual budget within curly bracket self dot budget, which actually shows the the budget of that particular city, and with a dollar sign actually that's just printing the dollar sign in front of the budget. So then what we will do is we will write the main body of the program. If or as soon as this particular code, the function ends, Python automatically understand that this is the end of the class, and now we are starting to create objects. Now the nature of the code actually tells Python that this is creation of objects. So it knows that this is the main body of the program. So actually it starts initializing from here. That is, city1 is the object that is created, and this is of type city. The city is the name of the class. And what is that? The parameters which are passed into that is Lucknow. Then there is the population, 40 lakhs, and then there is the the budget of that particular city. Then for city 2, it is Jaipur, and so on, right? And then city1 display.info. So when I'm calling the function, it is the function of that particular object. So when I'm creating the object, we have to say object of what type, of what class. And then when I'm calling the function, it is city1 dot displayInfo, means I'm calling the object, the function of the object city1, not of class. Of course, the object is the runtime instance of that particular class. So city1.displayInfo invokes the displayInfo function, which is actually taking that arguments, like when I have declared displayInfo earlier inside, we have described that in the class program. Automatically its job is to print the city name with the values that is passed to that particular object, right? So that is how we are able to give an output of city name Lucknow, population for this, annual budget this, and so on, right? So this is the first class program where we have first created a class, and then we have created objects of that particular class. Now in Python, classes are first class objects, same like we described earlier that functions are first class objects. Python classes are also first class objects. This means Python treated classes like anything like numbers, strings, list, it's a data structure or some sort of a structure. So same way classes are also treated. So a class can be passed as a parameter to a function. A class can be stored in variables or data structure. A function can create or return a class. So like functions, we're calling a function can be passed as an argument. Same way class could be also passed as an argument. Class can be returned. A class can be passed as a parameter to a function. So coming to the example, what we see over here are two classes, the maker and the building class. Whereas def maker, that particular Coming to the example, in this we can see a class called building, and within that, I don't want to write any arguments, that's why I have written pass, which is a placeholder in lieu of statements. I could have written many statements, because this is an example, I am written pass. So what I am doing is, whenever I am writing this, that means this class could be passed again as a argument. That means here I am calling the the function maker, def maker CLS. That means CLS is the argument which has to be passed, and the return CLS means CLS will be returned again. That same thing will be returned. That's the function of this particular. Just an example. That means this function actually returns whatever argument is being passed to it. Now I am passing in the final line x equal to maker building. What I am doing is I am calling the function, and then we are passing the class as a value. That means this building class is passed as a value, right? So that also is possible. So a class can contain attributes with any names, and these attributes can be created and accessed freely. The values assigned to class attributes may be simple data, complex objects, or even functions. And a class can inherit from another class. That means parent class's attributes and methods plus define its own additional features, as we learnt in inheritance. So if I have got a class called building, and it has got a function called def calculate FSI, where it is using and then what we can do is we can have a class called school with, where building is passed as the argument. That means we are inheriting that class, and then we can utilize def student capacity, which is, that we can add a new, function for that particular class, which is school, and then this will automatically have the capabilities of the initial class that we have decided, which is building. So that means def calculate FSI can also be called from this particular class. So let's see an example. So this is an example of inheritance in Python. So first we are defining the class building. So say as usual, we are having the constructor, that is def underscore init underscore self name floors area. So again we are saving name in name, self.name equal to name, self.floor equal to floor. Whatever argument is being passed is stored in these variables. And then we are having the function which is def building info, which is, just printing its own data, which we did earlier also. So it is printing its self.name, self.floors and self.area. And of course, and then we are defining a new class called school, and then within school I am passing building. So I am inheriting here, right? So def dot underscore init, here I am again, in addition to name, floors, area, we are also initializing student, because that is the new variable, or rather the new attribute that I have added, right? So in here I have been putting the values of initializing self.name, self.floor, self.area. Here I am adding self.student. But I also do have to initialize the first variables, right? So what I do is I call the underscore init underscore name floors area function, which we have defined earlier in the previous class. But how do I do that? I use this, this syntax, which is super. So super is a built-in function which is used to call a method from the parent class inside a child class. So that means we are calling the initialization method from the parent class, which is building, inside this child class, which is school, by using this super, this syntax. Now in addition to calling this function, we are also building a function. We can also call the function which is we can define a function within this particular program, within this particular class, which is school, and then we can also call the functions of the parent class as well. So over here we are defining a function called school info self, and within that we are calling, we could call it separately, but within that we are also calling a function self.building info, which is actually the function from the parent class. And then we print number of students, self.student, and then this is the end of the definition of class. Now we actually start the program, which says that school1 equal to, we are creating a class of type school, we are creating an object of type school, where we are passing the argument IIT campus school, that is the name, floors is 3, area is 5000, and student is 1200. And then I call school.schoolinfo, and when I call schoolinfo, automatically building info is actually called, right? Because it is part of the schoolinfo function. And then it prints the number of students eventually. So within building info, what is there? It will print the building name, floors. So eventually we see all the data will get printed. And as you can see in the output over here, building name, floors, built up area, number of students, all gets printed. The first 3 comes from the parent class and the parent class function, and the last one comes from the child class function. Then showing you an example of polymorphism in Python, what we have done here is we have defined 3 classes. One is a car class, one is a bus class, and one in a bicycle class. But what we have done is we have defined the exact same function. That means def calculate underscore travel time. So, and the arguments are also same, self and distance, right? So that means what it is doing is it is taking a speed value for car as 40, which is initializing inside this particular class. It's a fixed value, and then what we are returning is the travel time, which is definitely the distance divided by speed is the travel time. So that means that result will be different for car, bus and bicycle because the speeds are also different, right? So that means when now that after defining the three classes with the same exact function, now I am calling the we are creating the objects. We are creating first a car object, a bus object and a bicycle object. This is also a way this is the way we can write code where we are not initializing or passing any argument or anything. We are just, this car object is of type car, which is a class. Of course, this big caps and small caps, that makes the difference. I could have used something else. I could use a title like, okay, Maruti Suzuki, right? So that could be a car. Or bus, I could write Volvo as a bus, right? But I can use bus because small bus and bus in caps is basically the class and small bus is the object. So we are creating three objects, car, bus, cycle of type car, bus and bicycle class. And then I'm calling the function, car.calculate travel time and passing the argument of 10. And when I'm doing that, it is calculating the result as per that particular object, even though the value is, the name of the function is same. So this is an example, and then we are printing the result, of course. So you see the final result is car travel time is 0.25 hours, bus travel time is 0.4 hours and bicycle travel time is 0.8 hours, right? So now the question, we are saying we are calling this calculate travel time 3 times. So what is the point of all this polymorphism and so on, right? So what we can do is, instead, here we have called the function 3 times, right? And every time it gives you a different result because of the, even though the argument passed is same, but because it is, it is a function from car object or bus object, depending on the context, it is giving different results based on the calculations. But if I want to make it even, in a more complicated program, what can happen is, suppose I've got a list of modes like car, bus, bicycle, metro, tram, e-bikes and so on. Now, I don't want to write so many times. What I do is I run a loop. For m in modes, that means m starting from car, bus, bicycle, metro, each one will be executed once till it ends the, till this particular, loop ends the list. That means it reaches the end of the list. So it prints m.calculate travel time. So m value will change as per that particular list, that is car, bus and so on. So here, of course, there will be a end bracket as well at the end. So what it does here is, it will m.calculate travel time 10, because m is changing, I can have different results, right? So that means in each step it will print different results based on the context. That means this is an example of polymorphism, and here in one line I can achieve all this. I don't have to repeat 3 times, and that means that I can reduce the volume of code that I will write. So polymorphism reduces code. One loop, one function call works for every object. Then coming to a more detailed example, we are calculating travel times for various road segment in a simple road network. Now over here we are giving you a little bit more complicated example than the previous example, but more or less it's kept similar so that you can relate what's the difference. So here in this case we have got a class called road, then we have got a class called highway, then there is a class called arterial, then there is a class called local road, and again we are having a function which is like return self.length divided by 100, and which actually gives us that, okay, what would be the travel time in that particular road, right? So this 100 is the speed of vehicles traveling in highways. So 100 km per hour, in arterial it is 60 km per hour, and in a local road the standard speed limit is 30 km per hour. So obviously the total travel time would be more in each one of in local road compared to a highway, right? But again, this is the same polymorphism, similar to the polymorphism example. Now in the road class, which is from where what I am doing over here is, I'm now not only I'm showing you polymorphism, but this is where inheritance is happening. So that means first I am having a parent class which is called road, and I'm initializing it with 2 variables, name and length. So self.name, self.length. So that means these 2 arguments needs to be passed, and once it is passed, then we also have got a def travel time self, and this we are not giving anything because in the child classes we are actually having this function detailed out, and we will call that particular function travel time function, and the child class function will be called, right? So that's why we have not given anything. Even if this function was not there, it shouldn't have made much difference. So now we are writing the main body of the program. I have used the term def main. That doesn't, it's not required, right? If I put def main, I also have to add that last line. If underscore name underscore equal to this main, then what it means is road dot, that means in this particular case, in this particular case, this is actually এই জায়গাটা একটু কেটে দিও, if this particular case জায়গাটা আমি def main থেকে আবার শুরু করছি। Now coming to the main function, the def main network, what we are doing is we are first having a list of network where we are putting these values: highway, outer ring road 10, arterial, main street 5, local, market lane 2. So this is a data structure that we are putting in. We are having data on highways, arterials and locals, and now we can for roads in network. So that means now we are starting a loop, and what we are starting is that for every road in this particular list, we will store the travel time road dot travel time. After I run this, road is basically an object, right? As I told you, road objects are first class, these are first class, this can be treated as a data structure, so that's why I can run a loop with that as well. So road is an object, and then what we are doing is we are running the travel time function of that road and storing the result in this t variable, right? So and then what we are doing is we are printing the road name, of course, and then not only that, we are giving this 20, we are giving a 20 character size, so that's why this 20 is given, and then t multiplied by 60 basically converts hours to minutes, because initially we are getting it in hours over here, and then 1f formats it to 1 decimal place. So that's the syntax. So total is equal to sum total, the travel time, of course. That means if somebody is traveling some part in highway, then arterial and local, so that's why they must be adding, just for explaining this particular function. So total is sum r dot travel time for r in network. So r is the road object, and we can print this particular value, the total value that is being spent. So when you do that, when we run the particular loop for each of this particular road object, you can see that we are calculating the travel time, and this is where we are getting different results due to polymorphism, and eventually we are adding all these things up and getting the final value. So this is a little bit difficult example where we are combining several concepts of inheritance, polymorphism and so on, and then actually giving you that how this could be implemented together. Finally, we show you an example on agent-based simulation where we are trying to model vehicles randomly moving in an XY plane. Now to relate with it, sometimes taxis moving in a CBD area, they are searching for passengers, they move randomly. If I want to capture the idle time and the distance they travel, I need to do a simulation. Or for example, an autonomous shuttle is exploring a particular district. So that in these cases we may require something like this, right? But this is just to show you an example. Now this is a more complicated program. It's difficult to learn, explain everything altogether, but what I will try to say to you is that what we are building over here is, like, object-oriented programming allows us to build entities, and these entities interact, and then using those interactions we can actually simulate the different processes, and then we can see what are the results out of it. For example, if I want to create entities in an urban area, and then each of these entities interact with one another, and we want to see the results, what happens of this interaction, this is where we do agent-based simulation. So over here we have created different classes, of course, which represent the entities, but before that we have imported two libraries. One is the random library of Python, which is the inbuilt random number library in Python, and the other is the matplotlib library. This is used for visualizing and all. We will cover that in detail later on. We will not go into the detailed functions. So here we can create nice charts, we can level the charts, we can draw the values within that, we can plot those and so on. So the myplot module of this library is imported, not the entire library. And after that we are creating our first class, which is the vehicle class, and within this vehicle class we have a function called devStep. Both I will explain a little bit. So in the vehicle class we have a single moving vehicle on a 2D grid, and each vehicle has an ID. That means we can have many vehicles, of course. So that means each vehicle has to be given an ID, and that will change as per the objects. That means if I have 10 objects of type vehicle, then of course I will have 10 IDs, and a current location. That means where this vehicle is currently located, and a stored travel path for visualization. That means where it is currently located, and then how it is moving. Based on the movement, I need to also store that path, right? And that first part, the initialization constructor function you see over here, def underscore init underscore. So we can see that we are initializing this variables where x, y, the locations are initiated, and also we are adding this the travel. We are using a list x and y, which will be appended with the values of x and y in each step, so that we can store the travel path for visualization. Now in the step method, it shows that the vehicle can move in different direction. It could be either up, down, left, or right in a free in this particular free and roaming environment. 10 is up, -10 is down, 01 is right, 0 - 1 is left, or vice versa, right? So you can check that. So what we are doing over here is we are randomly choosing which one would be chosen, and once we have done that, we will add that to x and y, and then the path will be appended as well. That means the xy value would be changing. That means the current value of x and y will be changing, and then the path, we are also storing this value in that list so that we can keep track of the path. The second class, or rather in this particular case, in the second the program function, that is, we create a fleet of vehicles. This is the simulation step, right? So in this particular case, so in this simulation step, that means we are creating 10 vehicles and we are doing it in 20 steps. What we are doing is we are using a random seed. That means for every vehicle, first of all, it has got a unique ID, and then it has got a starting location and all. And that means we are also initiating that where it is going to start from. So that's why we are using a random seed in this particular case. And what we are doing is this range of vehicles, of course, has to be in the number of two loops are run. One is for the vehicle and the other is for the steps. So that means for each vehicle, and for each vehicle will run for 20 steps, right? So we are updating the steps part. That means we are calling the over here the step function. We are calling the step function, and we are returning this particular the value, and we are storing this particular, when we are returning that, we are storing this in the path. And then eventually once we have this particular function actually help us to simulate the entire this particular vehicles. And then finally we have the function for visualizing the vehicles. That means this is where we are using the matplotlib library, and we are using this plot and the scatter. We are actually putting them in an image, right, so that we can visualize them. And we are also putting labels to the image, the x position, y position, and so on. And then we can give a plot title. That means this particular chart or that particular plot can be given a title of vehicle movement on a 2D grid. And then we can do some amount of other adjustment as well, and eventually we plot.show displays the particular plot. Now that my class is ready, I can call that particular class in the def main, that is the main program. We are creating that particular this vehicles, and we are running the we are creating the vehicles, and we are running this particular simulation, and we can visualize this particular we are running this particular function visualize, and then eventually you'd be able to see this particular plot that is coming up. So you see, we can do different kinds of more advanced simulation program using this kind of object-oriented programming. So that is the reason that's the power of object-oriented programming, and that gives us very, very flexibility in planning, not only writing some programs and calculating something, but also to do very complicated interactions between objects and to eventually show what is happening out of those interactions, and we can do visualizations of those as well. So this is the demo of all the programs that we have just shown. So you can type in those programs to see what is happening. So this is the first program where we are showing the list of city names, then we are inheriting those. Then this is polymorphism program. We are showing you that how the same function could be called, but it gives different results in different contexts. And finally, we show you the simulation program, and here is the output of the simulation program, which you can also generate on your own if you type in this particular code. These are the references what we have used. To conclude, object-oriented programming enables us to model real-world urban systems using reusable classes, making complex interactions simpler, structured, and scalable. Thank you.